Hello and welcome everyone. This is Mohammed Abjawadi, an engineering student from Tunisia, and welcome to the first video in 0xp. So in this series, we're going to run computer simulations using OMNeT++. However, we cannot do that without first delving into the realm of computer simulations, understanding or having a basic grasp of what we're dealing with. Computer simulations are a tool often used by engineers whenever mathematical models fail them, whether because of models requiring many variables to come up with accurate results, or trying even more complex tools like Petri networks and then failing them again. So it's often the case that they want to understand complex systems, explore them, test and experiment with them, however they do not possess them yet. There's also the factor of costs that come with trying to understand complex systems, and it's generally the case that physical experiments require acquiring special equipment that require significant resources. There's also the risk involved with dealing with such systems. They may be hazardous, they may involve us in hazardous situations, and sometimes we just need to forecast and do predictive analysis and see how well do systems perform in future scenarios by modeling current data. Maybe we also want to optimize existing systems and we do not want to jeopardize production environments. These are all scenarios in which we want to use or utilize computer simulations, and we might consider them to begin with. So this series is going to focus on OMNeT++. However, in the end, or by the end, we're going to include other tools. The goal from this series is to familiarize ourselves with simulation software, understand the different types of simulation software out there, and to, by the end of the series, try to run different simulations with and try to simulate useful scenarios. So with all of that behind, let's delve in. So simulation is a crucial tool to understand and analyze systems without implementing them physically. There are different types, however, they can be categorized continuous or discrete. Continuous generally deal with differential equations or systems which have dynamism involved, and which generally we want to observe during small increments of time. There's also the discrete simulation type, which relies on fixed time steps simulations, as in we try to observe the status of our system after fixed time increments, or event-based simulations, a little bit more efficient, in which we observe the status of our system after events being triggered, so they do not have to have fixed time steps at all. Anyway, so in this series we're focusing on discrete simulations, specifically event-based ones, and we're going to run network simulations using OMNeT++. And in here you can find an overview video which discusses different types, and it can help you visualize what's going on. However, we're going to cover these examples. The first one deals with continuous simulations, and in here we are defining the equation for a simple harmonic oscillator, and we are plotting the variation of position and velocity over time. This is ideal, however, we cannot always do this because it's resource hungry, and yeah, when we're dealing with complex systems, it's going to cost us generally so much resources in terms of resources and in terms of time just to plot these types of graphs with a lot of moving parts. There's also the discrete event-based simulation, sorry, and in here we have an example for a queue length over time, so we can visualize this as the occupation of a message queue or a resource queue over time. Here with it being empty, and here with two elements in the queue. Here we can find an example for discrete fixed time step simulation, and we can try to experiment with the time steps variable, and we see how this affects our understanding of the system. So we can think of discrete event-based simulation as a special case for the fixed time step simulation. However, with it being a special case in the sense that we do not observe the status of the system unless there's an event changing. So in this series, we're mainly focusing on discrete event-based simulation, which is mainly useful in scenarios like package arrivals and signal transmissions and receptions, state transitions, etc. So they are extremely relevant when it comes to modeling communication networks, queue systems, and distributed systems, and this is why we picked this approach. So why OMNeT++, you might wonder? It's mainly because it's a tool mainly used by network and telecommunications engineers, and there's also the reason that it's designed around being modular, as in you need to create modules that communicate with each other, and together they form larger networks, which is really useful when trying to visualize, understand, or run simulations for large systems. There's also the reason that it's extremely customizable, which means that it's suitable for network research and development. And we can see in future series, hopefully, how it can be integrated with tools like SIMO 5G to try to understand 5G and simulate some of its underlying concepts. Sorry. Anyway, moving on to the installation, it's really straightforward. You go to omnetpp.org/download, and here you pick the system in which you want to install OMNeT++. I'm picking Windows, however, you can go with any of the following systems, and you can follow the installation guide if you're using Linux or Mac OS. So the steps are as follows. At first, you need to download OMNeT++, and then navigate to the folder. Well, for now, we do not have to configure the user. Run configure and make to build our executable. For the installation, after extracting and navigating to the extracted directory for OMNeT, we can find that we have the mango environment command. So let's start by running that. This should open this window, and in here we can run all of our installation commands. At first we configure, and after this is done we can start making the project. However, I already done that, so there's no need for me to do that. We can make, I've already done that. If everything goes well, we can start on it by writing OMNeT pp, and this should start the OMNeT++ IDE launcher. Here we can find an environment which looks like Ellipse. On the left we have the project explorer, in which we can find samples, and do not worry about making them all of them function. You should be prompted as well to install iNet, and you should probably accept that. Afterwards, let's try to run Aloha example. The default configurations should be fine, testing purposes, and here we have the simulation tool. On the bottom, we will be able to see different events when we run the simulation, and on the left, we can find different entities that are present and the scheduled events. So let's start the simulation and see how things go. So here we can find two transmitters creating collision at the level of the server, and after they detect that, they stop transmitting, and they will start transmitting after the time. Very straightforward. Not really efficient, but very straightforward. We should be able to wrap up the video, and in future ones we're going to see how to create our installations for different networking or telecommunications models. We're going to also try and test out different things and different frameworks on top of OMNeT++. I hope that you like this video. Make sure to like, subscribe, and see you next one. Take care.